The following data is given for an inventory system. Annual demand is equal to 24,000 units. Safety stock is equal to 400 units. Optimum order quantity per cycle is equal to 3,000 units. Calculate the reorder level when the lead time is 12 days and the number of working days in a year is 320. Here the reorder level is given by buffer stock plus lead time into Z, where Z is the annual demand, that is 24,000 units per year, and if you convert into days, here in a year the number of working days is 320, so Z is equal 24,000 by 320 gives the number of units required per day. So the demand per day. So now L is the lead time in days. So that buffer stock is reorder level is equal to buffer stock already given, that is 400 units plus 12 into 24,000 by 320, which gives a value of 1300 units. So in the option, the right option is A. A is the right answer. Two persons of weight 50 Newton sitting in a boat of weight 200 Newton, which is resting on water, and friction between water and boat is almost negligible. If the men run with a velocity 5 meters per second and jump in succession, then what is the boat velocity? And here the second question is, when both persons are jumped together from the boat with a velocity of 5 meters per second, then what is the velocity of boat? Here, in the first case, the men jump in succession. Succession means one by one. So here, the velocity of the boat when the first man ju jumps into the water with a velocity of 5 meters per second. So here 5 into 50 by 200 plus when here the total weight of the boat is 250 newtons, because 200 plus one person is already there in the boat of weight 50 newtons, so that is 250. And next when the second person jumps into the water, then it is equal to 5 into 50 by 200. So which gives a value of here 1 plus 1.25, that is 2.25 meter per second. This is the velocity of the boat. So in the option, the right option is D. D is the right answer. And coming to the second question, when both persons are jumped together from the boat, then velocity is equal to 2 into 5 into 50 by 200. So that the velocity of boat is equal to 2.5 meter per second. So in the option, the right option is D. D is the right answer. 20 meter cube of air per minute at 30 degrees centigrade and 60% relative humidity is cooled to 22 degrees centigrade dry bulb temperature, maintaining specific humidity as constant. Here properties of water are as follow. At 20 degrees centigrade, saturation of pressure is equal to 0.0425 bar, and at 22 degrees centigrade, saturation pressure is 0.0265 bar. And here take atmospheric pressure is equal to 1.01325 bar. So here it is a common data question. It consists of two questions. Here the first question is the relative humidity of the cooled air would be, and here the second question is the heat transfer in the process is. So here coming to solution, in the given data, at 30 degrees centigrade, P saturation is 0.0425 bar, and at 22 degrees centigrade, P saturation is 0.0265 bar. So but we know that here the relative humidity is given by the partial pressure of water vapor to saturation pressure. But here we will have to calculate relative humidity of the cooling air, and here relative humidity of the air at the entrance is given by 60% and is equal to PV1 by P saturation 1. So here PV, from this equation you can get here PV1 is equal to 0.6 into 0.0425, so which is equal to 0.0255 bar. And here coming to the specific humidity, here specific humidity is constant, so that here omega 1 is equal to omega 2 is equal to 0.622 PV1 by P minus P1. Here P is the atmospheric pressure and PV1 is the partial pressure of vapor at the instant 1, and here omega from this equation omega 1 is equal to omega 2 is equal to, you can get here a value of nearly 15.4 grams per kg of dry air. So these are the specific humidity values, and from the omega 2 we can get here 0.622 PV2 by P minus PV2. Here partial pressure of water vapor of cooled air PV2 is equal to, here it is equal to nearly 0.0255 bar, and we can have here the relative humidity at the instant 2 PV2 by P saturation. So here the saturation pressure of the cooled water is 0.0265 bar, so that it is 0.0255 by 0.0265, which gives a value of 96.25%. And in the options, the right option is C. C is the right option for the first question. And coming to the second question, here we will have to calculate the heat transfer in the process. So here heat transfer in the process can be calculated from the equation MA into H1 minus H2, and here H1 is given by 1.005 tree dry bulb temperature at the condition 1 plus omega 1 into 2500 plus 1.88 into TdB1, and in the same way H2 is equal to 1.005 TB2 plus omega 2 into 2500 plus 1.88 TB2. So by using these two equations we can get H1 and H2, so that here H1 is equal to 69.52 kilojoule per kg, and here H2 is equal to 61.25 kilojoule per kg, and mass of the air can be calculated from the equation perfect gas equation, that is PV is equal to MRT, and from this equation we can have the partial pressure of air is equal to 1 minus 0.0255 into 10 power of 5, it converts into Newton per meter square, and here the volume of air 20 meter cube per minute, and here R is 287 and T1 is 303, which gives a value of 23 kg per minute. So now substitute all these values in the heat transfer, so which gives a value of 185 kilojoule per minute. So in the options, the right option is A. A is the right answer for the second question. The turning moment